Hello everyone and welcome back. I am Benjamin Williams and today we're going to be doing another Boson NetSim lab within the infrastructure section within Boson. Today our lab is on HSRP interface tracking number 2. So let's go ahead and get into the objective for this lab right here. It says in this lab you will configure hot standby routing protocol, HSRP, and interface tracking. Hot Standby Routing Protocol is a network protocol that can be used to ensure the immediate and transparent recovery of client traffic from first hop failures and network edge devices by providing network redundancy for IP networks. Interface tracking enables HSRP to monitor a given interface and to automatically adjust the HSRP priority of a device when that interface goes down or comes up. So yes, that's a great description of what HSRP or Hot Standby Routing Protocol does. And also we're going to be implementing interface tracking as well to track the interfaces on these distribution layer switches. So if one of them goes down, we're going to decrement the priority, and then the other one, which is the standby switch, layer 3 switch, will take over as the active HSRP layer 3 switch. Okay, so here's our lab topology that we have for this lab. Looks like we have 2 core routers up here, and they're running OSPF in area 0 or the backbone area. We have Ethernet connections down to these distribution layer switches, and we have a serial point-to-point connection between the core routers. At our distribution layer, we can see we have a port channel, and the port channel that is bundled is the Gigabit Ethernet 01 and Gigabit Ethernet 02 interfaces. So this will allow for more throughput to be through both of these connections since they are bundled within an Ether channel. And then we have Ethernet links connected down to our access layer switches with some redundancy as well. As we can see, we have a connection here, and we also have a connection to D switch 2. So that's always good to have. And all of these devices look to be within VLAN 100. And we have our access layer switches, which give access to our PCs, give access network to our PCs. So that is always good to have, of course, if you want your device to get out to the internet. So that's the lab that's the lab topology. We've already read through all of the commands and also the descriptions for this lab right here. So that's always good to have. And also we have read through all of the IP address information. This is good to have as well for troubleshooting purposes, as well as to check and make sure that all of your interfaces on each device have the proper IP address and also subnet mask. So let's go ahead and get into our lab task. We're going to keep our topology up here in the top left. We're going to be doing our lab task readings in the top right. And we're going to be doing all of our configuration down here at the bottom. Okay, so let's go ahead and get into lab task number 1. It says configure HSRP. So it says in this task you will configure HSRP on D switch 1 and D switch 2. D switch 1 should be the active HSRP router when both D switch 1 and D switch 2 are available. Okay, so we want D switch 1 to be the active, and it says D switch 2 to take over for D switch 1 if D switch 1 goes down or the link between D switch 1 and D switch 2 is broken. Okay, so it says from PC1 ping core 1's loopback 0 interface, which has an IP address of 1.1.1.1. The ping should be successful. So let's pull up PC number 1 right here. All right, so this is PC number 1. Let's do a quick ping to 1.1.1.1. And we can ping core 1 from PC1. So that's just straight up through this access layer switch to the distribution layer switch, and then straight up to core router 1. So that looks good. It says on PC1, verify that the default gateway setting matches the IP addresses table. All right, so from PC1, let's do an IP config/all. And we can see our default gateway on this PC is configured to be 10.10.100.11. So let's go to our IP address table and look for the default gateway on PC1, and it has a default gateway IP address in the table as of 10.10.100.11. So that aligns and matches. So that looks good. Let's go ahead and scroll back up to our topology. Okay. All right, and it says for question number 3, it says based on the IP addresses table, which of the 2 distribution devices will become the active HSRP router if HSRP priorities were left to be at their defaults. So let's just scroll back down to that table. And if we take a look at this, these VLAN 100 IP addresses, we see that dswitch 1 would have an IP address of 10.10.100.11, and dswitch 2 has, for its VLAN 100 interface, it has an IP address of 10.10.100.22. So if we left the defaults, we left these two distribution layer switches at their default priorities, dswitch 2 would become the active because it has a higher IP address on its VLAN 100 interface. As we can see, it's .22 and dswitch 1 is .11. So we want dswitch 1 to be the active according to our lab instructions though. So what we will have to do is we're going to have to configure a higher priority on dswitch 1 so it becomes the active. Because if we left them at the defaults, like I said, dswitch 2 will become the active because it has a higher IP address on that VLAN 100 interface, okay? So right here for number 4, it says on dswitch 1, virtual LAN VLAN 100 interface, configure HSRP group 100 with a priority of 110. So yeah, like I said, we need to configure it with a higher priority. So it wants us to configure it with a priority of 110. So let's do an enable to go into user exec mode. Privilege exec mode. Sorry about that. And let's do a configure terminal to go into global configuration mode. And let's go into interface VLAN 100. And let's do a standby. And we want to do a group of 100. We want to do a priority of 110. Let's go ahead and hit enter there. All right. So it says based on the configuration so far, what is the maximum HSRP priority value you could configure on dswitch 2 without causing dswitch 2 to become the active HSRP router? So we would have to, the highest we can configure dswitch 2 priority to be is 109. Because if we go to 110, that means that dswitch 2 would become the active HSRP distribution switch because, like I said, it has a higher IP address. So the maximum we can configure dswitch 2's priority would be 109. And then if we look right here at number 6 on our instructions, it says on dswitch 2 VLAN 100 interface, we're going to configure the HSRP group 100 with a priority of 109. So like I said, that would be correct. Oops, I accidentally pressed, accidentally brung that whole interface up. I didn't want to do that. So let's, on dswitch 2, let's do an enable. Let's do a configure terminal. Let's go into interface VLAN 100. And let's do a standby 100 and do a priority of 109. Looks good, looks good. All right, it says for question number 7, it says on dswitch 2 VLAN 100 interface, configure HSRP group 100 with a virtual IP address of 10.10.100.1. So let's go ahead and do that. Now let's do a standby 100. Let's do an IP address of 10.10.100.1. Looks good. All right, and it says on dswitch 1, display HSRP information. Is dswitch 2 the active HSRP router? If so, why? So let's do a do show standby. And it probably is the active because we haven't configured the same virtual IP address on dswitch 1. So as we can see, dswitch 2 is the active because we haven't configured that virtual IP address of 10.10.100.1 on dswitch 1. So that's why it is the active. So number 9, it says on dswitch 1 VLAN 100 interface, configure HSRP group 100 to use a virtual IP address of 10.10.100.1. Let's go to dswitch 1. Let's do a standby 100. Let's do an IP address of 10.10.100.1. All right. And now it says on dswitch 1 and dswitch 2, display HSRP information. Has the HSRP role on dswitch 2 changed? If not, why not? So we can see right here that dswitch 1 is in the standby mode. And the reason that it's in the standby mode is because preemption is not enabled by default when using HSRP. So since we configured the virtual IP address on dswitch 2 first, it's automatically going to stay in the active mode unless we have preemption enabled. And like I said, preemption is disabled by default, as we can see from this output. So we could do that on both routers. Let's do a do show standby on both routers. So we can see that it still is the active router. And let's go to D switch 1. We do the same thing here. Let's do a do show standby. And this one should be in the standby mode, which it is. And we have to enable preemption. Like I said, preemption is disabled by default. So if we enable preemption, D switch 1 will take over as the active router. All right. So it said, question 10, it says, on D switch 1 and D switch 2 display HSRP information. Yeah, so we just read that. Okay. On D switch 1 and D switch 2, enable HSRP preemption for HSRP group 100. What do you notice about the router roles after preemption has been enabled on each device? So after we enable preemption, D switch 1 will take over as the active router because it has a higher priority than D switch 2. So let's do a standby 100 preempt. Perfect. And you can see that it took over as the active role as soon as we enabled that command. Let's do the same thing on D switch 2. We can see that D switch 2 has went into the standby mode because it has a lower priority. So let's do a standby 100 preempt. Looking good. So it says on A switch 1 and A switch 2, configure the HSRP virtual address as the default gateway. So let's bring up both of our access layer switches. Let's give an enable for privilege exec, conf T for global config. Let's do an IP default gateway of 10.10.100.1. Looks good. Do the same thing on A switch 2. Enable, configure terminal. Let's do a IP default gateway of 10.10.100.1. Looks good. All right, it says on PC1 and PC2, configure HSRP virtual IP addresses as the default gateway. So let's bring up PC1 and PC2. So first we're going to start on PC1. Let's do a IP config / default gateway of 10.10.100.1. Looks good. Let's do the same thing on PC2. Let's do an IP config / default gateway of 10.10.100.1. All right, good. From PC1, for question number 14, it says, from PC1, ping core 1's loopback 0 interface, which has an IP address of 1.1.1.1. And it says the ping should be successful. All right, so let's do a couple of up arrows. All right, we can see we have that ping to 1.1.1.1. And we are getting replies back from core 1's loopback 0 interface. So that is good. It says we sent 5 and we received 5. So that looks good. It says, from PC1, trace the path to core 1's loopback 0 interface 1.1.1.1. What path does traffic take from PC1 to core 1? Why? So it should go through D switch 1 because that is the active distribution switch for our HSRP group. So let's do a trace RT to 1.1.1.1. We can see that the first hop IP address that we're reaching is 10.10.100.11. And if we look at our IP address information, we can see that D switch 1's VLAN 100's IP address is 10.10.100.11. So that is correct. And let me bring this back up to the topology. I just realized that we still had the IP address information over there, but that was good information to have for that particular question. All right, question number 16, it says, from PC2, trace route to core 1's loopback 0 interface. What path does traffic from PC2 take to core 1's loopback 0 interface? Why? Well, it will take the same path that we just took for PC1 because, like I said, D switch 1 is our active distribution layer switch. So, oops, I actually did a ping. I'm wanting to do a trace route. But we can see that all of those pings were successful. Let's do a trace RT to 1.1.1.1. Yep, and it's using that same path that PC1 took First it's going to D switch 1, and then it's going up to core 1, core 1's loopback 0 interface. Okay, so task 2, it says configure and verify interface tracking. It says in this task, you will configure interface tracking on D switch 1 so that HSRP will automatically lower its HSRP priority when the path between D switch 1 and core 1 goes down. Perform the steps in this task on distribution switch 1 unless otherwise specified. Okay, so number 1, it says what benefit does interface tracking to automatically lower the HSRP priority of an active router provide to clients of an HSRP group? So if we look at our topology, we can see that D switch 1 has this connection up to core 1. But if this interface was to go down and traffic from clients are still trying to get out to trying to get up to core 1, like I said, if this interface is down, we don't want to continue to try to use this link because the interface is down and our host will not be able to reach core 1. So if this interface goes down, what we want to do is we want to lower the priority on D switch 1 so that D switch 2 will take over. So traffic from our end clients will go through D switch 2 instead of D switch 1, and then they will be able to go up to core 2 and then over to core 1. So it will basically give us redundancy within our network and still allow our end devices to get out to the internet or get out to whatever destination they're trying to reach if one of our interfaces fails. So that is a benefit of using interface tracking, okay? So it says examine the topology. It says what interface should HSRP track in order to automatically decrement the priority of D switch 1 when the link between D switch 1 and core 1 goes down. So we want to track this fast Ethernet 01 interface on D switch 1, okay? So it says right here, it says configure HSRP group 100 to decrement D switch 1's priority by 1 if the line protocol of D switch 1's fast Ethernet 01's interface goes down. So we just identified that in the last question. So let's go ahead and apply the configuration now. Let's do a standby 100. Let's do some context sensitive. We want to track that fast Ethernet 01 connection, and we want to decrement it by 1. So let's go ahead and enter there. And now it says display HSRP information. Is D switch 1 still the active HSRP router? What is D switch 1's priority? So it is going to be the active router still, and its priority is going to be configured for 110. But let's go ahead and confirm that. Let's do a do show standby. And like I said, we still have the active role on D switch 1, and we can see its priority is still configured to be 110. Okay? So it says shut down the fast Ethernet 01 interface. Does D switch 1 remain the active HSRP router? If not, why not? Well, after we shut down this interface, it will not be the active HSRP router. It will become the standby because D switch 1 and D switch 2 will then have the same priorities, which will be 109. And we know that D switch 2 has a higher IP address on its VLAN 100 interface, and we have preemption enabled. So in that case, D switch 2 is going to take over as the active HSRP router. So let's do an exit on D switch 1. Let's go into interface fast Ethernet 01, and let's do a shut. And as we can see, our interface tracking state has moved from up to down. Okay. All right. And yep. We now see that D switch 1 has now went into the standby mode, and D switch 2, if we look, has went into the active mode. Okay, so that just confirms everything that we said. So it says display HSRP information. Is there a difference between D switch 1's HSRP priority and D switch 2's priority? Well, their priorities are both going to be configured to 109 now, but we can confirm that. Let's do a do show standby on both distribution layer switches. Let's do show standby. We can see that D switch 1's priority is 109, like I said. Let's do the same thing on D switch 2. Let's do a do show standby. And we can see that its priority is also 109. So that confirms everything that we just said. All right. So it says on PC1, trace route to core 1's loopback 0 interface. What traffic is PC1 taking to Core 1's loopback 0 interface? Well, now it's going to go from PC1 to A switch 1 to D switch 2 to Core 2, and then it's going to go over to Core 1. But let's confirm that. Let's go to PC1 and let's run that trace route again. And as we can see, we're going to D switch 2 first, because this is D switch 2's VLAN 100 IP address. Then we can see it's going to Core switch 2, and then we can see it's making its way over to Core switch 1. Okay, so that looks good. So it says on D switch 1, re-enable the fast Ethernet 0-1 interface. Does D switch 1 assume its active HSRP role? And yes, it will, because it will have a higher priority once we re-enable that fast Ethernet 0-1 interface. And we do have preemption enabled. So D switch 1 should receive its active role back. So let's do a no shut. Okay, let's give it a few seconds. Yep, and as we can see that within those few seconds, D switch 1 has now taken back over as the active HSRP role. Okay, let's just confirm. Let's do a do show standby. And as we can see, it is the active HSRP distribution switch now. And we can see our OSPF adjacency just came back up. So that looks good. So this is the end of this lab right here. So let's grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.